We present a novel mechanical keyboard, blending traditional keyboard-centric desktop work with elements of natural user interaction, such as touch and gestures. Our goal is to enable fast, easy, and low-effort gestures, allowing users to smoothly transition between text entry and motion-based gestures so that hands always remain in the home position on the keyboard. Gestures can enhance traditional desktop interaction, for example, switching between applications using hover gestures above the keyboard. Or navigating documents with coarse swipes and pinch to zoom. And even gaming, such as controlling this race car with a virtual steering wheel. Our first contribution is a novel, thin form factor keyboard prototype. The motion keyboard can sense rapid motion directly on top of the keyboard and in a narrow band of hover without the need for any external sensing. A 16x4 sensor array of infrared proximity sensors is interspersed with the keycaps of the mechanical keyboard. Sensor nodes are surface-mounted on a PCB, which is inserted between the keycaps into the silicon rubber membrane, which it sits underneath. At 64 pixels, the sensor data is very low res, but fingers and other parts of the hand moving above the keyboard are visually discernible. A novel readout scheme allows us to drive the sensors at high frame rates above 300 Hz. A further contribution is a novel gesture recognition approach. The key idea in our approach is that of motion signatures. First, we accumulate a binary motion history image. By forming a weighted sum of binary foreground masks over a sliding window, older frames receive a lower weight. We also form an intensity motion history image, a running image of raw intensity frames. All frames are incorporated using the same weight. Together, the intensity and binary motion history images form a motion signature for each gesture. We collected and labeled a large database of example gestures and trained a random forest classifier on this corpus. Our system is capable of robustly recognizing a large set of challenging gestures. Here we show a number of gestures performed on keyboard, of dynamic and static nature. It copes with significant variance in inter-subject gesture execution, as well as differences in the speed in which gestures are executed. Our approach can also classify a number of gestures performed in a narrow band of hover above the keyboard. While we haven't fully explored the design space of all possible gestures, we think the system can enable a rich set of compelling and useful interactions which tightly integrate gesturing with regular desktop work. For example, in document navigation and zooming. Accurately localizing 2D fingertip locations in a low-res image is difficult with traditional approaches. However, as shown here, early results indicate that it is possible to use the raw sensor data in a nearest neighbor database lookup scheme to retrieve high-res images from a database of ground truth imagery recorded in an offline process. This ground truth data may be used to track fingertips and enable full touch-based interaction. In this video, we presented the Motion Keyboard, a thin form factor mechanical keyboard with built-in gesture sensing capabilities. Thanks for watching.